So today, what am I going to talk to you about today? So we're going to talk about random data generation in the context of testing. Yes, it's working. So we know that there are a lot of types of tests. Obviously, we don't just have unit tests. We have, for example, we have integration tests. And we know that unit tests are not enough. I don't have much time, so I'm just going to assume that everything is on the internet is true. So I found this on the internet. This is a great explanation of why you should write integration tests. The reason why you can do that, you need to do that, is that you can create a system with components that perfectly well by themselves, but are not exactly on sync. So please don't just write unit tests, write integration tests. So what we are going to discuss today is how to write integration tests when you have limitations, like side effects. So the most common approach when writing unit tests is to, OK, I'm going to use what I call static fixtures. What that basically means is that you have a huge trait with lots of predefined data, and you just use that data over and over again over your tests. And that's kind of work, but not quite, because first of all, it's super boring, right? We don't like boring. And then we have things like this, when we're like, yes, I wrote an integration test, so my system will definitely work. And then we discovered that our integration test was actually testing one little tiny case scenario in our system. So for example, this poor guy actually tested the system, but because it was pouring the water directly into the drain, it didn't detect that actually his system wasn't working at all. By the way, thank you, Twitter. You're amazing for this kind of presentations. All of this example can be found on Twitter. Obviously, there is a better way of doing these kind of things. Another approach that lots of people are using is called ScalaCheck. And who has used ScalaCheck before? OK, quite a few people. That's good, because this is not a talk on ScalaCheck. It's a talk on how to steal ScalaCheck code. You will see that in a second. So ScalaCheck is basically about writing properties and checking that those properties are valid. You are not going to provide test data, but ScalaCheck is going to automatically generate examples of your data. And if you define a property that is not true, in case of failure, ScalaCheck will tell you, no, this property is not valid because, for example, with this input, it's not going to work. So it's quite a cool approach, right? It makes you confident that your code will probably work, right? We can never be sure, but hey, this is cool. But there are some cons as well when using ScalaCheck. For example, there is some knowledge to gain. It's not always that immediate to rethink your test's properties. It can take a while. And your ScalaCheck is not a mathematical proof that your code actually works. ScalaCheck will just repeat the test a certain number of times, and if all the tests pass, then it's going to assume, yeah, the property is true. Doesn't mean that it's true for all of them? No. And also, when you have side effects, because ScalaCheck is just repeating the test over and over again, this could cause serious problems. For example, if you have a database, it's just going to smash the database 100 times or whatever your configuration is, and maybe the database that you're using on your CI tool is going to fall over. Thank you, Twitter, again. This is a great example of what I was saying before. ScalaCheck results are dependent on the configuration. So, for example, Noel is working with dates. So he had a specific bug, and he used ScalaCheck to try to test it out. Default configuration for ScalaCheck was repeat the test 100 times. He couldn't it couldn't replicate the bug. It had to change the configuration to 10,000 repetition of the test to actually highlight the bug. And then he went crazy, right? He said, OK, I'm going to put 1 million repetition. And he actually found the bug of the Java library. So these kind of things you need to be aware of that could be problematic when using ScalaCheck. So I work for PayTouch, and we had a similar problem. So we have this fatty service that every company has, even though we know we shouldn't, that is called core, that has way too much business logic, but hey, that's life, with a dedicated database, with some communication with other services, internal services, and a third party, and the REST API. And because this is our fat monster that everyone depends on, we really want to test it well. So we said to ourselves, OK, so we use Postgres. And Postgres is not great to simulate in memory, so we have to use a real database. And because this is the fatty service that everyone depends on, we want to really test it really well. So we decided to go for behavioral-driven development, BDD. What that means, basically, that each test is going to represent a requirement of what your API or service, whatever, can do. And because of this limitation, we quickly wrote 600 tests that run in about 4 minutes, because they are full integration tests. So they hit the API, they go through the service, and they hit the database. And we couldn't use ScalaTest because, ScalaCheck, because, as I said before, ScalaCheck just repeats the test many, many, many times. So if we were using to use ScalaCheck, we would have run the test 60,000 times, and it probably would have taken a lot longer than 4 minutes. And also, we had another problem. We are a startup, right? We're not Netflix. So we have to keep our costs fairly low, and we cannot afford to pay lots of money for our CI tool. So that was really an option. So what we have seen so far is that we kind of have two approaches. The static fixtures approach, where we predefine all the test data, that is completely biased. And then we have the ScalaCheck approach that is super cool. The test data is a lot less biased, but has a limitation when you want to do proper integration tests that involve side effects. So the question is, can we find the middle ground? Right? So middle ground will be, OK, we're going to run the test once, but instead of using the static fixtures, we are just going to use random fixtures. And spoiler alert, we're going to do it, and we're going to do it on stage. Yes! Cool, then let's do it. Cool, so what we are going to do then is basically we want to have a magic function, then given a t, is going to return a random instance of t. Cool, but we are lazy, right? We could implement this by ourselves, but guess what? We don't want to do that, because we don't have a lot of time to dedicate on this project. So we have this amazing project that is called ScalaCheck that kind of already does this thing. Can we somehow steal some code and make it work for us? So let's have a look at the source code of ScalaCheck. It turns out that the class that is responsible of generating the data is called gen like generator. And this obviously is a simplification. There is this method that is quite cool. It's called sample, and it will return an option of a t. OK, so it's cool. It's a little bit weird, because you would expect that sample would be a t. So we do a little bit of digging around, and turns out that the reason why they return an option is because later on, they do some further filtering. For example, you could say, generate all the a list of characters such that all the characters are letters. This is their implementation. So we're just going to steal it. Cool. So we added somehow we will get some gen. We will do get sample and then screw safety, .get. Right? It's going to be fine. Trust me, it's going to be fine. OK, cool. Next step is how the hell are we going to get a gen? So it turns out that there is a class in ScalaCheck that is called ARBITRARY. And believe me, this is the whole implementation that just includes a generator in our scope. Yay, almost there. Done. It works. Kind of works, though, right? Because how am I going to get the arbitrary of t, right? It's not anywhere in the scope. So something that we could do is every time for every type, we could write an arbitrary, right? That could work. That would be extremely boring as writing the status fixtures. So is there a better way of doing that? Obviously, there is. Thank you, Shapeless. There is a project that is really good that I strongly recommend it to you if you are using ScalaCheck that is called ScalaCheck Shapeless. It basically uses ScalaCheck, it basically uses Shapeless to generate the arbitrary automatically for you if you have an ADT, meaning either a sales trait or if you have a case class. So that's it. We had the that magic import, org.scalacheck.shapeless _. Yay, we are done. Super cool. How cool is that? 4 lines of code, right? And it works, right? So you can do random string and you will get the crazy thing. You will do random int and you will get this number. Or you can do random int and get another number. And then have a case class bro with some things, and it will be able to generate it. Cool, done. And we can use it, right? It is exactly the same, the usual way we are used to write tests. We don't have to rethink how we write tests. The only difference is that instead of calling our magic trait with tons of biased data, we just do random user. But are we really done? So one of the things that we want to do when testing is obviously once we found some data that we know is problematic, we want to be able to reproduce the issue, right? Because we need to understand if it's actually a bug or maybe it's some data that doesn't make any sense. So can we make this in a way so that somehow on demand we can make this test deterministic? And what we really want to do is to have somehow print some message when we run our test saying, hey, by the way, the seed associated to this session is this thing. And if we know that that session is problematic for us, we just want to fix it somehow in an environment variable, really. So if we go back to this implementation of generator, we see this function sample here that has this weird seed.random. They don't have a function to pass a seed into a sample, so we're going to steal their code. Ta-da! Done. So what we have done here is that somehow we will generate a long, either randomly or reading from an environment variable. Is not really important. But what we are going to do, instead of calling sample, we will call the implementation of sample, meaning that we will pass some default parameters and the seed that we selected. Cool. So that works. So we have done this work, and it turns out to be extremely useful for us. So useful that we decided to write a small library on it that is called random data generator. We have done some tweaks to take care of some edge case scenarios, but I'm going to be honest with you, the core is there. The core is those 4 lines. So it's pretty sweet, right? We have done nothing. We have taken some code from ScalaCheck, some code from ScalaCheck shapeless, and we put them together, and we have created a tool that is pretty cool. Let's see how it was useful for us. So the first thing that we noticed is that suddenly we didn't have to maintain this huge boring trait of fixtures anymore, because now when using the test, we just have to declare random user, and then shapeless is gonna go by itself and see what actually user is. So if you add a removal field to user, your tests will still compile. The other thing that we noticed is that readability of the test itself really improved. Because, for example, if you have a test that is testing that your user has a specific age, all you have to do is to say, I want a random user, but age with a specific value. So in a way, this forces you to highlight the piece of data that are relevant for your tests. So basically, what we have done is that our tests now are using different test data every time we run the test. But still, we have the opportunity of making these tests deterministics. And then something amazing happened. Bugs everywhere. And this is great, right? Because we were able to catch and fix bugs without the customer realizing it. So we managed to make our platform fairly stable. So that's great for a startup, right? But obviously, you know, this is a tool, and like every tool has pros and, I wouldn't say necessarily cons, it's more things to be aware of. So a few things that we learn by using this tool. The first one is that obviously shapeless does a lot of things, but unfortunately is not able to do everything. So every once in a while, you will have to write the arbitrary manually. For example, if you have a currency from java.util is not a case class, it's not a sealed trait, it's a Java thingy. So the compiler doesn't know, well, shapeless doesn't know how to generate a random instance of a currency. So all you have to do is to say, okay, I'm going to create an arbitrary of currency that is an arbitrary that contains a gen one-off of all the currencies that I can see. And it works. The other thing that we learn is that, as I was mentioning before, when a test fails, you are going to find yourself asking, is the code broken, or is the test data that I've generated valid? So you do need to be aware of being able of generating data that makes sense. So for example, for us, we were storing a string in a database. And because of Postgres, this wasn't really good for us. Our database was blowing up every 5 seconds. So we said, okay, let's just redefine what strings means for us. And what we did is string, arbitrary string for us, is a generator of alpha string, where alpha string, it just means list of characters where each character is a letter. And it works, right? So every time we generate a string now, it's going to have this shape rather than that shape, because this is what we are interested in. Obviously, though, sometimes shapeless is able to generate an arbitrary, but maybe it's not good enough for you. So you want to define for a particular type a custom arbitrary. So for example, you could have a person and say that a random instance of a person has a name that is one of these 3 values and has an age that is between 0 and 100. Right? So every time that you are going to generate a person, you're going to have a shape like this. Make sense? Yes. Cool. And now a little bit on the not so cool stuff. So obviously, like any shapeless project, the compiler does a lot of things for you, right? So it makes your life easier. But obviously, the compiler has to work harder. So you will, unfortunately, see an impact on the compilation time. The good news is that the type level people are really working hard on it. So this is an image from ScalaCheck 2016. So it was in London this December, and it's from a presentation that Miles gave, working on a new way of resolving implicits, inductive implicits that are the one that Shapeless is using. So this was the current implementation, and this is his implementation. So for big case classes, for big derivation, his fix really helps a lot. So this was in December, was his proposal, amazing, do it. And he has done it, yes. So there is a PR that has been merged in type level Scala, and there is an open PR that hopefully is going to be merged soon in lightband Scala. So things are getting better, right? It's just a question of waiting a little bit longer, and everything is going to be great. But in the meanwhile, obviously, we still need to compile our code, right? So what we can do in the meantime is just caching as much as possible the arbitraries that we know we are going to reuse over and over again. And one of the way of doing this is to just use something really cool that is called cached implicit, that it's in shapeless. And what you can basically do is have an object, declare all your implicit variables, and just say cached implicit. So every time you want to use a cached instance of arbitrary of A or arbitrary of B, all you have to do is just to do import cached arbitrary implicits dot underscore. And all your cached arbitraries will be in your scope. This helps a lot. But obviously, you need to do the effort of recognizing that an arbitrary is used over and over again. So there is still some human effort to do there. Another thing that is really important is that random data generator is for testing. Obviously, you could use it in other ways, like I'm going to use it to just populate a test database and simulate an environment that has some data in it. Of course, you can do that, but because we reuse ScalaCheck, and ScalaCheck has been implemented for the purpose of testing, the way ScalaCheck is generating data is completely biased. So he will try the edge case scenarios a lot more than those that are not considered to be edge case scenarios. So if you use random data generator to just populate a database, I'm going to warn you, you will find, for example, lists that are extremely short and lists that are extremely long. So be aware of that. Probably there are better tools out there to just generate amount of data. So I wouldn't suggest to use this tool for this purpose. So my suggestion is to use it for testing. So let's wrap up a little bit what we have seen. So what we have seen is that a compromise between the approach of just generating static fixtures and going all the way with ScalaCheck is possible. It's so possible that we implemented it on stage. And this is cool. And the reason why it's cool is that it improves our integration tests so there are less bias. Obviously, there is always going to be a little bit of bias, but it's definitely better than just specifying a huge trait of tests of data that we are going to reuse over and over again. The second thing that we discussed is that it's really important to be aware of what it means for you having some generated data. So be aware of the data that makes sense and the data that doesn't make sense in your domain. As we said, the generation of data is going to be biased. So a lot of edge case scenarios, so use it for testing. Don't use it to populate a database. because it's going to be problematic. And obviously, I'm going to stress this one. Don't ignore random failures. The test is run once. So if your test is randomly failing, it's not the CI tool problem. It's probably your code that is broken for a specific shape of data. So every time you run a session, you will see the seed number. So take note of the seed number, reproduce the session on your local machine, try to understand what's going on. Is it the code that is broken? Is it the generated data that is completely nonsense? And try to fix either one of the two. And finally, a little quote from a guy that you probably heard of it. It was my nightmare at uni. That is remind us why it's so difficult to test, right? And the reason why it's so difficult to test is that you cannot prove that something works. You can only show that there is a bug in something. So no matter how many tests we can write, we can never guarantee that our system works always. So that's everything I wanted to tell you. If you guys want, have a look at Random Data Generator. That's the link up there. And if you want, that's my Twitter account. I'm going to post all the slides there so you guys can have a look at the code and convince yourself that works. And that's my blog. Thank you, guys.